All right, so we're going to graph some polynomials. We're also going to talk about some end behavior. We can find the degree, the leading coefficient, the y-intercept, all kinds of stuff. The first thing you may notice, here I say graph using 1/2 as the interval on the x-axis. Now, I recommend this so that we can see as much of the turning points and we can see a little bit more detail on our polynomial when we graph it. To show you what this looks like, when we're looking at our calculator, we want to go to the table setup menu. You hit second window, it pulls up the table setup menu, and notice right here that my delta table, I have that set to 0.5. That is a half. It's counting by halves on the x-axis. So now when I go to my table, notice that the x is counting by halves, and I have my outputs for each of my two functions that I've already plugged into y equals. So those are the two functions we're looking at. So let's graph these. For this first one, well, remember some things that we know. We know that the y-intercept is going to be at -4. We know that the right side of the graph is going to be pointing down, the other side is going to be pointing in the other direction, so that helps. I'm only going to plot the points that I can really fit on here. I've got at -2, I've got 12, so it is quite a ways up here, but that might help me to see what's going on. When you connect the points, you want to make sure you're doing it with probably as most smooth lines you can. You can look at the actual graph on your calculator to help you think, all right, how do I need to connect these so that it looks correct? And so here's the first one we got. Notice, again, right side's pointing down, left side's pointing up. We knew that by the degree and the leading coefficient. Our end behavior here is our x's approach positive infinity, it's pointing down. So our y values are going to negative infinity. As we look to the left, as our x values go to negative infinity, f of x is going up to positive infinity. Our degree, we know our degree was 5. Our leading coefficient, we know that was a -1. Our y-intercept, we know is a -4. The actual number of real zeros, it only crosses the x-axis once. The actual number of turning points, looks like it has 1. We do some bobbling in here, but really I see 2 turning points, 2 places where it really does change direction from decreasing to increasing or from increasing to decreasing. I'm going to graph this one real quick. All right, on the second one, again, the degree was positive, or our leading coefficient was positive, meaning the right side's pointing up. Our degree is even, so both sides are pointing in the same direction. Our y-intercept was 4. Both ends are pointing up. That's both going to the right and going to the left. Our y values are pointing towards positive infinity. Our degree is 4, the leading coefficient is a +1, the y-intercept was 4. How many real zeros do we have? It never crosses the x-axis. The actual number of turning points though, 1, 2, 3, I see it change direction 3 times.